Hey guys, welcome to Brain Code. So in today's video, we'll be solving the problem of the day, that is jump game 4. So basically the problem states that you are given with an array integer and you are initially positioned at the first index of the array. In one step, you can jump from index I to I plus 1, where I plus 1 should be less than array dot length, and also I minus 1, where I minus 1 should be greater than or equal to 0. So, and also you can jump to an index j where array of I is equal to array of j and I should not be equal to j. So we need to return the minimum number of steps to reach the last index of the array. And there is one more case that you need not to jump from outside of the array at any time. So the given test case, we'll look into the test case and we will get a better idea. So if you check 100, you will be standing at the first index, that is 0th index, and you can move to I minus 1 or you can move to I plus 1. So if you try to move I minus 1, so in the first condition only it is stated that I minus 1 should be greater than or equal to 0. If you try to jump to I minus 1, you will go array index out of bound. And if you try to jump to I plus 1, you will reach to minus 23. And there is one more thing, that is j, where array of I should be equal to array of j and I not equal to j. So if you check here, you can move to minus 23, from 100 to minus 23, or you can move from 100 to directly at the index 4, that is 100, because here the index at I and the index value at 4 is same. So that is what the third condition states. You can jump to j where array of I is equal to array of j and I is not equal to j. So you can move to 100. So in this case, you will try to move 100. Now in the 100, you can move to I minus 1 or I plus 1, and you cannot move back to 100 because we have already came from that array. If you try to move back from that array, you will stuck in a loop and you will always try to move between 100 and 100. So we need to handle this edge case. So if you check here, you can move to I minus 1 or I plus 1. So we will be moving to I minus 1 because if you check with our naked eye, we can say that if you move to 404 and you can move to I plus 1 or I minus 1, or else you can move to the same value at the index which is present at the last index. So if you move at the last index, we have reached the end of the array. We can tell directly by seeing the array, but how we are going to solve this problem? So I'll be explaining this in my iPad for better understanding. I think you can see my iPad screen as well. So we are given with an array 100 minus 23 minus 23 and 404 and 100 23 23 23 3 and 404. You will be standing at the first index. You will be writing index as well, 0 1 2 3 4 5 6 7 8 and 9. So you can move to I minus 1 or you can move to I plus 1. Here, or you can directly move to the index where the number is equal. In this test case, we have moved to 4th index. Now from 4th index, you can move to 404 or you can move to 23. We will be moving to 3rd index. Now you can directly see that from 404, we can directly move at the end of the array. If you think about this problem, we will get an idea that we are checking whether the element is visited or not. Visited or not. Whether the index is visited or not. And also we can move to multiple places. And also we should track each index values. We should track each value index instead of each value index. So if you check this question, you will get an idea that it can be solved if these three contents, it can be solved using graph, and with this graph you will be using BFS traversal with a hash map, and this hash map is used to track each value index. BFS is used to move to multiple places. Now, and one more thing, we need to have visited array so that we can move to the next element, and if it is visited we can ignore it, so that we will not stuck in a loop. So how will be solving this? We know that in a BFS algorithm you need to have a queue. You will be having a queue you will have a hash map, and you need to have a visited array as well, so that you can mark if there is any visited node. Visited array. So in BFS algorithm we will be moving the first node, and we will be removing and checking the size and moving the level wise. So first we will be pre-computing all the hash map values to it. So first, if you check now, for 100 here key is value, and key is num, and value is a list of index. Yes. So if you check 100, we will be having, we can directly store at what are the places 100 is present. So if you check in the array, 100 is present at 0, we'll be taking 0. Next, 100 is present at 4, we'll be keeping 4. Next, you got minus 23. At minus 23, minus 23 is present at index 1, at index 2, and that's all. And 23 is present at index 5, index 6, and index 7. And you are having one more value, that is 3. 3 is present at index 8, and you are having a value 404. It is present at index 3 and index 9. So first we will be pushing the first index. We have pushed the first index, that is 0. Here we will be writing the size, that is number of iterations, and the steps. So currently we need to run until the queue is empty. I think you know the BFS algorithm, I guess. So if you check the size of the queue, that is 1, and the size will be running in the loop, and the step currently is 1. So now we are running the loop, So the size becomes 0 and we will be removing this element. Now we'll be storing 1, current is 0, and we'll be removing this from the array, sorry, queue. So now the current is equal to 0. So whenever you got a current, first thing we are going to do is check the current double equal to n minus 1. This is last index. Second. So current, it will be checking the first one, whether it is equal or not. Then the second step what we are doing is, we will be checking if current minus 1 is greater than or equal to 0, and it should not be visited. So, and add current minus 1 if this is true. Else, first thing, if you check the current minus 1, so the current is 0, and if you do 0 minus 1, it will be minus 1. So you cannot add it. So this step will not execute. And we'll be checking one more step, that is, you can move to I minus 1 and you can move to I plus 1 as well. And you check whether current plus 1 is less than n. And it should not be visited. If it is there, then add that current plus 1. So check now. 0 plus 1 is less than n. And to add current plus 1. So in the visited array, what we are going to do is, for the 1, we are making it as true because we have visited 1. And we are adding 1 to the queue. And also we should also check whether the given number is present in any of the index. So for that, we will be running it. First, we'll be check in map whether the current is present or not. Like, not current, that is array of current. Whether array of current is present. If it is present, then you will be having a list in this. So we will be running an index in the array map.get of current. In mp.get of current. And if it is not visited, current, then you add that to queue and make it visited. I think and increase the steps whenever the size becomes 0. I think this is enough to solve this problem. This is the pseudo code. Basically, we need to follow in the each step. So we got one. So now we'll be checking in the map whether 100 is present in any other way, at any other index. If you check carefully, it is present at index 4. So what we'll be doing is, we will be marking 4 as true because it is visited, and we'll be adding 4 to the queue. The next thing what you need to do is, if you check the size of the array, it is currently 2. So we'll update the size, and the step becomes 2. Now we are removing the 1 from the queue. So the size becomes 1 and the current becomes and we are removing 1 from the queue. And we are having current as 1. Now check current of n minus 1. You check the current at 1. You check that n minus 1. At index 1, you are having minus 23. And if you check at index, oh, I forgot to write this one as well. You just write that one. Making 0 comma true because 0 we have visited at the start of the node, at the start of the problem. So check, now 0 is visited. So we will not execute this one. Now check if current, so current is 1 here. If you add plus 1, it becomes 2. And check whether 2 is less than n. Here n is 9, sorry, here n is 10. Here n is 10 and 2 is less than 10. So, and check in the visited whether it is 2, whether it is present in that or not. So it's not present. So this case is okay. So what we are going to do is we will add 2 in our visited map, sorry, visited array. So next what you need to do is you need to check it whether this 23 is present at other index as well or not. So in the hash map, if you see, minus 23 is present at 2. But if you check in the visited array, 2 is already present. So we will not be adding 2 to our queue because it's already visited. So now what we are, now the size becomes 0 and the current becomes 4 because 4 is left in the queue. So now we are at 4. We are at here. So what you can do is you can move here or you can move here. You can move to minus 1 or you can move to plus 1. That is 3 and 5. You are at 4, you are standing at 4. So for that one, if you want to move to the minus 1, the current is 4. So 4 minus 1 is equal to 3. So check 3 is present in the visited graph, visited array or not. So 3 is not present in the visited array. So what you are going to do is you will be adding 3 in the visited array and making it as true. Now the next is you can add 23 as well. So if you check at the index 5, we are having 23, but it is not visited. So make it 5 comma true. And we are adding first 404 and we will be checking, and we will be adding 23 as well in the queue. So you will be checking whether any of the index apart from 4 is there any 100 present. But if you check now, we have 0 and 4, but we have already visited 0 and 4 at the start of the index where we are having 0. So as we are having 4 and 0 in the visited array, this won't execute. This won't execute. So now the size becomes 0 and now the size becomes 2 and we are removing 404 from the queue. Now the size becomes 1 and the step count becomes 3. So you are left with 23 in the queue. So 404 is present. You'll be checking whether the current is at n minus 1. Now the current is at 4 and n minus 1, 4 is not equal to 9 because 4 is present here and you need to reach here. So it is not possible for now. So we'll be checking. You can add at 3. The current is at 3. So current is at 3. Now what you can do is you can add 3 minus 1 or 3 plus 1, any one. So if you add minus 23, you check in the visited array, 2 is already visited, so we will be not adding that. And if you check the 4 is also visited, so we'll be not adding that. And now when you come here, you'll be checking whether 404 is present apart from any of the index. So it is present at index 9. So what we are going to do is we are adding 9 here. So after adding 9, we are marking as visited 9 comma true. Now after 9, you will be checking the current. The current is 23 now. So the current is at 23. 23 is nothing but it is at 5. So what we are going to do is we'll be removing this, make it 0. Now instead of 23 it is 5. So we are having 5. After that you can add 5 minus 1 which is already visited, and you can add 6 as well. So when you add 6, you can add 6 in the queue. So check whether 23 is already present somewhere. It's also present on 7. So you add 7, make it 6 as true and 7 as true. Now you remove 5 from it. Now you are removing 9, and you will be checking whether it is at the last index or not. If you check, the current is at 9. The size of the array is also 9. So we have got it. So we can return, we have reached the end of the array. So you can return it as true. I think that's all with this iteration. Now I'll be coding that. Okay, so first thing what we are going to do, first we'll be creating what are the things which required. For that, first int equal to array dot required a variable which stores the length of the array, and you required a visited array which boolean, and you also required a hash map source integer and a list of integer. Got hash map as well. Now what we need to have a queue which contains integer and it is list. So first we will pre-compute return hash map I less than m, then I plus plus, then we'll be adding that to second. There is a little typo here. Okay. Now what you can do is compute if absent comma new list of user dot add of I. For computing, we will be adding q dot add of the first index and making instead of 0 is equal to true. And you will be writing the DFS algorithm is empty. What we need to take is we will be having int is equal to 2 dot size will have int steps equal to 0 at the start. Size I plus plus. And then the first thing what we'll be checking is if you'll be removing, you'll be having the current value, that is q dot, and if current is double equal to n minus 1, you can directly return steps. And also we need to handle one more edge case, that is if there is only one variable, you can directly return 0 instead of doing all this. So I'll do that. If n double equal to 1, you can directly return 0. So here we have handled that single element edge case. Then one more thing what we need to do is if current minus 1 is greater than 0 and n not equal to instead of current, then you can add that q dot add of that current and make it instead of current is equal to true. Then if current plus 1 is less than n, it should be greater than or equal to 0. Current plus 1 is less than n and if not equal to instead of current, what you can do is q dot add of current, then instead of current is equal to, make it true. Now there is one more case that you need to check in the loop as well. So you need to check in the hash map if np dot a key of array of current, then we'll be running a loop because it contains an list of integer inside the hash map. For that one, what you need to do is, hey Saho, hi. And for that one, what you need to do is, for int index for int indexing, you need to take that visited app. You need to take empty dot get of current, and you need to check if visited of index, if not equal to visited of index, you can directly add that app. Hey Saho, hi. If you are new to the channel, please consider subscribing the channel and liking the videos. So if you are having any doubt, you can ask me, Saho. Not equal to visited of index, what you can do is, you can directly add of that index and make visited of index is equal to true. So once you are done with this, we will write steps plus plus. Here we are returning steps, and if it is not possible, we can directly return -1. I think I have written everything, so checking they're passing or not. So somewhere I have done a mistake, cannot be initiated. Cannot find symbol. P is empty. Oh, sorry, P is empty should be written in this camel case. It is absent. No array list. It is present. Oh, I think it contains. I think it contains the lambda expression. Dot add of I think this should solve this problem. So for the test case, output is 3, but we have written -1 by. So we got complete array of I, and we add of I, and we are adding and making it true steps. We are taking it to, and we are also having a boolean that is n is empty, size is also q, size and I plus plus. We are checking it is current double equal to n-1, we are returning. And oh, I missed a small case here. Current of I-1 should be, and here it should be current of +1. Then you can, if mp dot contains key of array of current, for int index in mp dot get of array of current is not equal to visited index. We have made it, then we have added to queue. And I think once we are done with it, we can remove as well, because remove of array of current. So with this, the time complexity will be more even less. And here it will be running only size of n times. I think somewhere around step for time limit exceeded, I think. But if I don't remove it, maybe the remove is taking extra time. Would be fine. Oh, I forgot to do this as well. We need to add current plus 1 instead of current. And instead of current plus 1 will be true. Plus 1 here and plus 1 here and minus 1 here and minus 1 here. If current double equal to I minus 1, you dot add of current of I instead of current I minus 1. So through you dot add of index and instead of index. I think now it's better, I feel. Yeah. So we'll submit the problem. Yeah, we have solved it in somewhere around 48 ms. We'll check that 0 ms. What's the difference they have done? So here they have pre-computed, queue visited, they have taken count and x, and they are running loop. So they are just making this as well, like they are adding some extra conditions to make it more even optimal. I think that's not needed. So if you write this, I think this is enough for the optimal approach. So for this, the time complexity will be big O of n, and we are running one more loop inside it. So, but it will be running because we'll be like, once we are running the loop, we are removing the current in, we are removing the current index as well. So this might be more optimal if you remove this. So here the search space will be even more less when you compare to it, and the index will be depending inside it. There will be like very minimum values. I think that is okay, I guess. And the time space complexity will be O of n, and we are using a hash map, and inside we are using a list of integer, and we are removing as well. So that won't take much space as well. So here also we are using O of n. I think this is the most optimal approach you can write. If there are any questions, I'm happy to answer. I think Saho, are you here? Are there Saho? Okay, that's all for today, guys. I hope you like the video. So if it's helpful, consider subscribing the channel and liking the video as well. So that's all for today. Have a great day.